Welcome, this is an IXL support video. Specifically, we're going to be taking a look at the first assignment in Cluster Y, the one that focuses on linear equations. For this lesson, we're going to be focused on the assignment Y.1 called Find the Slope of a Graph. So as we click into this assignment, I'm going to make the whiteboard a little larger and I want to talk quickly about slope. This assignment says find the slope of a graph, so we really need to understand what slope means. Slope, at its basic definition, we could say slope is the rate of change for a linear relationship. Or even simpler, we could just say, as the whiteboard shows, slope is the rate of change. In blue here, a way to understand that, slope is really going to be a number or a fraction that describes to us how much the y value changes by each time the x goes up by 1 unit. And that's what we mean by the unit rate of change. So to figure out what the slope is, sometimes I'm going to be given a graph, and when I'm given a graph, this expression, rise over run, is very helpful to keep in mind for slope. Because if I'm on a graph, as we take a look at here, the y-axis is represented by the vertical, or the up and down axis. So however much I rise by, the numerator in this slope ratio, that's going to tell me my y change. And however much I move right or left by, which I use the term run to refer to left and right movement, or sideways movement, that tells us the x change. So for every single graph, the big key here, let me make this a little bigger first, I need to pick out 2 points on this graph in order to be able to find the slope. So as we zoom in here, I'm going to use my marker tool, let me load that up, and I'm going to mark 2 points on this graph. I would encourage you to do the same anytime you're asked to find slope on a graph. You need to focus on 2 data points from that line. I'm going to use this point right here because I see it's on the black line and right on a corner of a grid box. I'm going to keep following this line, and I'm going to mark a few others. Right here would be a good data point to use. I'm not going to use the one up here where my mouse currently is, but that would also be a good data point here. The reason I call them good data points, they sit right on the corner of these grid boxes. They line right up with your x and y axis, and they make it easy to measure the slope. So first I'm going to measure rise. I'm going to count how much I need to travel up on the y-axis by, and we need to count up by 4 units. We go from 0 all the way up to 4. So I travel up by 4, that's my rise or my y change, positive 4. And during that time, all we had to do was travel right by 1 unit. It goes from 3 over to 4, it traveled right by 1 unit. So that tells me that my slope then, I have a rise of 4, a run of 1, so my slope here is going to be 4 over 1. Here we see another graph shown. So again, the big key recapping to measure slope, it's rise over run. So throughout this assignment, your main job is going to be to find 2 data points and measure the rise over run, which will tell you the rate of change or the slope. Here I see 2 data points. It climbs up by 3 units and it climbs right by 1 unit. So when I see it goes up by 3 and right by 1, the slope is 3 over 1. And let me go ahead and lose that camera for now. And that's how we get to a slope of 3 over 1 for that one. So I'm going to provide a few more examples. I don't believe this assignment gets that much more challenging. Your job throughout is usually just to be able to find the slope of a line, and hopefully we can find a few that have negative slopes are more challenging, because in the beginning they've given us a few very similar ones. Here, part of my challenge might be, you see, for this line I would not be using the x-intercept where my mouse currently is, because that's not on the corner of a grid box. Here I see 2 nice little corners I could use. That helps me measure an exact rise of 3 every time it goes run or moves right by 1. So that's again a slope of 3 over 1, or I could simplify that even further. As they asked me to simplify, I could just write 3, but as you'll see, they'll also accept 3 over 1. Okay. Another example with positive slope, and pretty straightforward. We see y-intercept at 5. By the time x is 1, y is 7. It climbed up by 2 over by 1. So there's our slope of 2 over 1. I'm going to punch in a few quick answers just to see for this assignment. It may just give you positive slopes. Okay, finally one that may be a little more challenging. We're going to show this example. Your slope is not always going to be a whole number, an integer. The bigger number is not always necessarily going to be the rise. And here's our first example of one. It has an x-intercept of 5. It has an x value of 5 when y is at 0. And the next good data point I see here, x is 7, where I'm putting my red dot right here. Well, the y value is now 1. So the y value gained 1. We went up by 1. As the x value ran or moved right by 2, which is gaining 2 there. So we have a slope here of 1/2. I'm not going to continue going here. It does look pretty straightforward. We're up to a score of 82, so I'm usually going to stop the IXL videos around 80. I hope this was helpful. If you've got questions on IXL, carefully read their explanations, but you can also send me an email and I'm happy to jump on and help you out like this. Thanks for the hard work so far, and thanks for checking out the video.